Right. Assalamu alaikum. Now, there's a small part. There is one more reaction that I have to say, right? That we have missed here. So, after preparation of Grignard, these are the reactions that would happen, right? Now, if you take in this case, you will get right. Finally, we wrote it. So, if you write with water, you will get CH3 plus MgOH In the case of ammonia, you will get CH3 plus CH3 plus MgNH MgNHBr, right? And in the case of phenol, you will get CH3 plus CH3, sorry, CH3 plus phenol MgBr. So this is a thing that you have to know. So finally, there is one more reaction. You can produce amine from alkyl halide, right? Amine. So CH3CH2Br. If you react this one with ammonia, you will get CH3CH2NH2. CH3CH2NH2. So finally, we are completed with alkyl halides. Understood? Now we are going to go with the alcohols, right? Right. So there are so many things to be considered, right? In these cases, right? Now we have to see the next term is alcohol. So now you are going to see the reactions of alcohols. Going to see the reactions of alcohols. Now see here in alcohols, we'll see the case of making alkyl halides, right? You can make alkyl halides, right? So once you have alcohol, let's say CH3CH2OH. So if you put concentrated HCl or concentrated HBr, you will get, right? This is one of the steps, right? You can do in this manner also. You can get CH3CH2Br or CH3CH2Cl. There's another way. You can either use for CH3CH2OH as PCl3 or PBr3, right? Or you can use PCl5. So in this case, you will get CH3CH2Cl or CH3CH2Br. So this is the main case once you consider about the alkyl halides. Okay. Second one, formation of ester. Let's say esterification. 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 Now you are having CH3, CH2OH. Once you put carboxylic acid, and use the reagent concentrated sulfuric acid, you're going to get an ester. CH3, C double one O, CH2, CH3. This is called esterification. Right. Third one, you can say oxidation. There are two methods to oxidize an alcohol, right? So number one, CH3, CH2OH. If you use H plus KMnO4 or H plus K2Cr2O7 or H plus CrO3. If you use them, you will directly get a person is none other than carboxylic acid. Okay, so this is the case over here. Let's say if I am using this one with another reagent, CH3, CH2OH. If you are using PCC, pyridium chromide chloride, right? You are going to get CH3, C double bond H. This is actually an aldehyde. This is actually an aldehyde, right? This is actually an aldehyde, right? This is actually an aldehyde, right? So this is actually an aldehyde, right? Now for the fourth one, you can react this one with sodium, right? You can react this one with sodium. So if you react this one with sodium, CH3, CH2OH. If you react this one with sodium, you're going to get CH3, CH2ONe plus to gas. An evolution of gas will be taking place. Instead of that, you can use even sodamide. Right? In this case, you can do in the same way. Right? So this is the reactions based on alcohols. Right? The reactions of the alcohols. So finally, we are done with the alcohol part also. Alhamdulillah, we are done with the alcohol part also. Now everything will become small, right? This is your main junction. So you will understand once you do the conversions here. I will explain you through the model paper also. Now let's see the next one, right? Now we'll see the next one. So the next one is actually the aldehyde. The aldehyde. So normally in aldehyde, you know, you can use Grignard reagent and all. You can use Grignard reagent. And let's say now you need to identify, right? So identification test of aldehyde. Identification test of aldehyde, right? So now RC double bond H. Let's say RC double bond H is there, and you are going to use 2,4 DNP. DNP means dinitrophenyl hydrazine. Dinitrophenyl hydrazine. You can draw the structure like this. Sorry. NO2, NO2, NH, NH2. So this is the compound that is called DNP. Usually DNP is used to identify the ketone and aldehyde, right? So if you use DNP, right, the compound that you're gonna get is actually like this: R C H double bond N NH NO2 NO2. So this is during the dehydration process, after the dehydration process, right? So this is the compound that you're going to get if you use this and if you heat them up. If you heat this up. If you did not heat them, the compound that you're going to get is like this: R C H OH N H H in H. You're going to get NO2. You're also going to get NO2. Right? So by heating this up, right, if you heat this up, or you can say dehydration means removal of water, right? Dehydration, this system will remove the water and form this product, right? Right. There is one more test, right? There is one more test. So keep in mind, there is one more test. There is one more test. Right. Right. Using tolerance reagent. So you can say this one as Brady's reagent, right? This is Brady's reagent. This complex is actually a orange precipitate. This is an orange precipitate. Now only for aldehyde this is possible, right? So in this one you have aldehyde plus ketone. You can use this one to identify ketone also. But specifically for identification of aldehyde. So if we use RC double bond H, right? If we use Tollens reagent, Tollens reagent. Tollens reagent means you are going to use Cu2 plus tartrate, copper tartrate under basic medium. Copper tartrate under basic medium, right? So copper tartrate means Cu NH3 4 times 2 plus under basic medium. So you will get this RC double bond O minus. You will get this fellow oxidized along with Cu2O, right? Along with Cu2O. So this is actually brick red sorry my bad. sorry, it is in buffer tartrate. Tollens reagent, it is actually AgNO3 NH4OH. So this is a basic medium. If you use this, you're gonna get this one oxidized along with the precipitation of silver. Ag, it is precipitated. Since this is precipitated, you will get a silver mirror due to this. Silver mirror. You will get a silver mirror. Right? Alhamdulillah. Right? Now see, now this is your second identification test of aldehyde. Now in this third case, now let's see what will happen if you put Grignard reagent, right? Grignard reagent. Let's say my Grignard reagent is CH3 MgBr. Okay. If I use CH3 MgBr to C double bond H, right? In first step, I'll be using R C double bond. In first step, I'll be using CH3 MgBr. In second step, I'll be using acidic hydrolysis along with water. You will get RCH. This H will be coming towards this side. H, and then you will get CH3. You will get OH over here. So what you are going to get is you are going to get a secondary alcohol. You will say this one as a secondary alcohol. You will say this one as a secondary alcohol. That's what happens once you put Grignard reagent. Now let's see the reduction phases, right? Let's see the reduction case. Let's see the reduction of aldehyde. In the reduction of aldehyde, in first step, let me use lithium aluminium hydride or sodium borohydride in AbH4. So if I use lithium aluminium hydride, keep in mind this is the first one, right? Let's say this is your first one. So when RC double bond H, in the case RC double H for sodium borohydride, the same product will be formed, but some of them will put methanol. There's no harm. Methanol, there's no harm. You will get the same product over here. Okay. Now what I'm going to do is I'm going to use Clemmensen reduction. Clemmensen reduction. This can be done for both ketones and aldehydes. You can do it for both. What you are going to do is the reagent that you're going to use. Now see here, RC double bond H. Once you use zinc amalgam concentrated HCl. Once you use zinc amalgam and concentrated HCl, you will get RCH2, CH3. You reduce this completely by removing just two bonds and putting two hydrogen. So you'll get an alkane. This can be done for this also. Now there is one more identification test that I missed in the alcohol. Sorry. See here. There's one more identification test, right? That usually comes in the structure questions. right? If the question that they are going to ask is about alcohol, mostly they'll put this kind of tests in it, right? So one thing is that they'll use Lucas reagent, right? For alcohols, it's for Lucas reagent. In the Lucas reagent, let's see, you're getting ROH, right? Let's try it. Let's take a break for the answer and we will do it the class in another 15